All right, good morning, guys. Today we're going to be doing 9.1 Introduction to Area. This is the start of Unit 9, which will be all about two-dimensional figures in space. So to begin, for area, we can always think of area as the amount of space that a two-dimensional figure makes up. Since we're dealing with area, we're on a flat surface, so it will be in two dimensions. Now, when dealing with area, it's typically going to be measured in square units. That's why you see things such as feet squared, meters squared, inches squared. All these things are to the second power, meaning that it's squared. So anytime that you deal with area, your answer for area will always be in units squared, whatever those units may be. Now, imagine that each of these boxes, so we have a little box here, are 1 square inch by 1 square inch. In other, it's a 1 inch by 1 inch square. Now, if I were to multiply 1 inch by 1 inch, I get 1 inch squared, or 1 square inch. And a good way to think about this is if I gave it a variable x, we know that the area of a square is just area is equal to length times width, or base times height. I'll stick with base times height for today. So this would just give me x times x. And we know x times x is just x squared. So that's where the square comes from, in inches squared. It's just inch times inch, or inches squared. So anytime that you deal with that, deal with area, you're going to be dealing with inches squared or meters squared or anything like that. So for a quick example, you guys have probably done this in the past, but we're going to find out how many square inches are in the following shapes. So back in the day, typically you just start counting. It'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and you keep going the entire way. Another way to do that is to split it up into sections. So I have a 5 by 5 section, so I know that this is 25 square units with inside this blue block, or I can just count them and get 25. I have 4 inside the red, green, and purple blocks. Not exactly 4, but about 4. It's pretty close. And again, it's not going to be exact on a circle. I can see that I have 1, 2, 3, and then all these little pieces together, they make almost 4. And same thing over here, 1, 2, 3, and then almost 4. 1, 2, 3, and almost 4. And of course, these aren't perfectly 4. They're going to be a little bit underneath that. Then for our orange side, I have about 5. Not exactly 5, but just about 5. If I add up all these sides together, 25 plus 4 plus 4 plus 4 plus 5, it'll give me about 42 units squared. Now again, it's not perfectly 42 units squared, it's about that. It's pretty close, it's just an estimate. And over here with the rectangle, if I have a rectangle, then of course we can see that we have 3 rows, and we have 8 columns, so therefore I can just do 8 times 3, or I can just count up 8 3 separate times. Either way, my final answer will give me 24 units squared. So that leads us to a postulate. This postulate states that two congruent shapes have the same area. So if I have two congruent rectangles or two congruent triangles or whatever it may be, as long as they're congruent shapes, if I find the area of each of those shapes, those areas will always be the same. But is the converse true? If two shapes have the same area, are they congruent shapes? And the answer is not always. Here I have a rectangle and a square. My rectangle is going to be 2 by 8, and my square is going to be 4 by 4. If I find the area for each of these, I'll get 16 units squared for each area. So as we can see, they have the same area, but one is a rectangle, while the other shape is a square. So no, it doesn't mean that they will be the same shape, but it doesn't mean that they're not the same shape either. It gives the possibility of them being the same shape if they have the same area, but it doesn't necessarily mean that they will be the same shape. So there's always a chance that they could be. It's much more common that they're not going to be the same shape, even if they have the same area, but you will run into some that are congruent. All right, so first off, the first shape that we're going to be dealing with today is triangles. Now, first off, when we're dealing with triangles, we should remember that the area of a triangle is 1/2 base times height. Now, this first bullet point is extremely important. The height is the altitude of the triangle. And when we see the word altitude, I know that the altitude intersects the opposite side at 90 degrees. So that means that the base and the height must always be perpendicular to each other. They must always intersect at 90 degrees. And that's extremely important. You're going to hear me keep saying that as we go through this video. But again, height and base must always, always, always intersect at 90 degrees. For obtuse triangles, if I have an obtuse triangle, meaning one of my angles is larger than 90 degrees, if I have one of those triangles, the altitude may be on the outside of the triangle, and we'd have to draw auxiliary lines in order to find that altitude, in order to find that height. So of course I can see the height is on the outside, and it intersects at 90 degrees to the extended base. So I draw my auxiliary line extending the base out, and we still have that 90-degree angle. Again, super important that height and base intersect at 90 degrees. Now, it doesn't necessarily mean that it'll always be outside the triangle. No. Let's say that this green side was my actual base. Let's say that I called this B instead. Well, then my height would still need to be perpendicular to that base. So in this case, this would be my height. So again, it depends on which side you choose as your base. And again, that leads us to remembering that each side of a triangle can be the base. Any side that you choose as the base, just make sure that your height intersects at 90 degrees. That's the important part. The last triangle that we have, besides right and obtuse triangles, is of course an acute triangle. And with an acute triangle, the acute triangle's height will always be on the inside of the triangle. And again, we can see that it intersects the base at 90 degrees. So again, make sure that your height and your base are always perpendicular to each other, meaning they intersect at 90 degrees, as shown in each of these triangles. All right. Next up, we have parallelograms, rectangles, and squares, all shapes that we should be familiar with. The first shape that we're going to talk about is a parallelogram. Now, again, our formula hasn't changed. Area for all of these is going to be base times height. And as we go through these, you're going to see them throw in different variables like length and width or side squared. Just keep in mind that it's still going to be base times height. That's what we're going to keep with, and that way it's just consistent all the way throughout. Now, for our parallelogram, it's important to know that the height is not the side length. The height, again, must be perpendicular to the base. So again, this green side here, this is not the side length. This is not the height. So this green portion is not the height. The height must be perpendicular. So if you're ever given this, this is called a slant height. It's the height of the slanted part of our parallelogram. So we're not going to use the slant height, at least not for area. We'll use it down the road once we get into pyramids and once we get into cones and finding the volume and surface area and all that stuff of those shapes. That's when we're going to be using slant height more so. For now, we really just want height. For a rectangle, rectangles are length times width, but just keep it as base times height. You don't need to change. And again, within a rectangle, since they all have 4 right angles, we know that the height and the base are always going to be our side lengths in a rectangle. And then lastly, with a square, of course, with a square, we can still use height and base once again. And of course, since the height and the base are the same within a square, it's always just going to be side squared. But again, you don't need to remember all these different variables, length and width and sides, as long as you remember height times base. You should be good as long as you remember that. So let's go ahead and try out some example problems. Our first one, we want to find the area of this triangle. Now, first thing that we need to do is identify our base and our height. In this problem specifically, our base is 15 centimeters and our height is 10 centimeters. From here, we can plug that into our area formula for a triangle. Area of a triangle is equal to 1/2 base 15 centimeters times height 10 centimeters. 15 centimeters times 10 centimeters will leave me with 150 centimeters squared. I'm still multiplying that by 1/2. Half of 150 centimeters squared will leave us with 75 centimeters squared for the area of this triangle. Next up, we have a parallelogram. So again, first, determine what is our base and what is our height. So in this case, our base is 26 and our height is 17. Plugging it into the area of a parallelogram, the area of a parallelogram is just base times height, or in this case, 26 inches times 17 inches. 26 inches times 17 inches will leave us with 442 inches squared. So the area of this parallelogram is 442 inches squared. All right, next up, find the area of this obtuse triangle. So again, we first must identify our base and our height. In this case, our base is 15 and our height is 19. And I know this because the base and the height should always intersect at a right angle. We see our right angle right here. So that means that our base is 15, just the part of the triangle, and they just extended it with an auxiliary line, and the height is 19 centimeters. And again, we'll always draw that auxiliary line in order to find out the height within obtuse triangles. From here, we plug it into our area formula. Area is equal to 1/2 base, 15 centimeters, times height, 19 centimeters. 15 centimeters times 19 centimeters will leave us with 285 centimeters squared. Half of 285 centimeters squared will leave us with 142.5 centimeters squared for the area of this triangle. All right, now let's focus in on equilateral triangles for a minute. The area of an equilateral triangle can be found using the equation side squared times radical 3 over 4. Now the way that we get here is by using special right triangles. So first off, if it's equilateral, we know that equilateral triangles have all sides and angles being congruent, meaning that each angle is 60 degrees and each side length is s. Now if I were to draw my altitude from one of my vertexes to the opposite side, it will not only intersect at 90 degrees, making it the height, but it will also split that 60-degree angle perfectly in half, giving me two 30, 60, 90 triangles. So therefore, I can use my 30, 60, 90 triangle. The side opposite 30 is x. Side opposite 60 degrees is x radical 3. And the side opposite 90 degrees is 2x. Of course, I know that 2x maps on to this portion right over here of my equilateral triangle, which is just side length s. So therefore, s is equal to 2x. And if that's the case, that means that x down here, this bottom portion, is just half of s. So if x is equal to half of s, then the height, x rad 3, should be 1/2 s radical 3. That would be the height or the altitude of our triangle. Plugging in our height and our base, s, into our area formula, area is equal to 1/2 base, s, times height, 1/2 s rad 3. 1/2 times 1/2 is 1/4. S times s is s squared times radical 3. That is the area of any equilateral triangle. And again, that's the same exact formula as the one right down here. Area is equal to s squared rad 3 over 4. Again, these two are the exact same thing. So make sure that you have that squared up or somewhere on your notes where you can easily find it and use that formula down the road. Let's go ahead and use this formula now to find the area of an equilateral triangle with side length 8. So we plug that into our new area formula. Area is equal to 1/4 times side squared, which is 8 squared, times radical 3. Well, 8 squared is just 64. So I have 1/4 times 64 rad 3. 1/4 is the same as dividing by 4. So 1/4 times 64 is the same as 64 divided by 4. Either way, we get 16 radical 3 as our area. If we enter that into our calculator, that's about 27.7 units squared. All right, now let's go ahead and move on to some more difficult problems dealing with parallelograms. So, we want to find the area of this parallelogram, and it has side lengths of 16 and 10. So, is 10 the height? Is 10 the height of this shape? Well, no. 10 is the slant height. Remember, our height must be perpendicular to the base. So therefore, I'm going to go ahead and draw an auxiliary line going straight up from this point, straight up. And what that does is it will create a 90-degree angle here, which makes this into a 60, 30, 90 triangle. So that's one of our special right triangles. Side opposite 30 is x, side opposite 60 is x rad 3, side opposite 90 is 2x. The only side that I have is 2x, and that maps with 10. So therefore 10 equals 2x. If that's the case, then the top portion here, x, must be equal to 5. If x is 5, then our height, x rad 3, should be 5 radical 3. From here, we have our base still, which was 16, and we have now found our height, 5 rad 3. The area of a parallelogram is just base times height, or 5 rad 3 times 16. 16 times 5 is 80, so our area is 80 radical 3 units squared, which if we enter into our calculator is about 138.6 units squared. Next up, we have an obtuse triangle with side lengths 6 and 14. We have an included angle of 30 degrees, and we want to find the area of this triangle. Now, if I want to find the area of this triangle, since I have side angle side, I can use our area formula for using trig, and I can solve for it that way. But I'm going to go ahead and use special right triangles here. So I have this 30-degree angle and this 90-degree angle with the auxiliary lines, which means that this full angle up top must be 60 degrees, making this into a 30, 60, 90 triangle. Side opposite 30 is x, that'd be our height. Side opposite 90 is 2x, and side opposite 60 is x radical 3. From here, I only have one equation here. 14 equals 2x. That will allow me to solve for x. Dividing both sides by 2 gives me x equals 7. And in this case, x is our height. Right? It intersects at 90 degrees. Further, our base is just 6. It's not going to be the full length here, because again, our triangle ends at this point, because this is all auxiliary line. So therefore, our base is just 6. To find the area of this triangle, area is equal to 1/2 base times height, or 1/2 of 6 times 7. 6 times 7 will give me 42. Half of 42 will give us 21 units squared. Only a few more questions left, and then we'll be done with this lesson for today. Find the altitude of a triangle with an area of 1,298.5 inches squared and a base measuring 53 inches long. So we have our triangle here, and again, we know that our base is 53. We don't know our height, we'll call it h, and we know our area is 1,298.5. Plugging it into our area formula, area is equal to 1/2 base times height. We get 1,298.5 inches squared, our area, is equal to 1/2 times 53 inches, our base, times h, our unknown height. Again, we just want to solve for h. So I can start this off by getting rid of the 1/2. To get rid of the 1/2, I multiply both sides of my equation by 2. That will leave me with 2,597 inches squared equals 53 inches times h. Lastly, to get h by itself, I divide both sides of my equation by 53 inches, and that will leave me with h is equal to 49 inches. Of course, we can see that the square and the inches cancel out, which which just leaves me with inches here. So that's why it's not inches squared or anything, or just 49. It's because all I have left is inches for units. Our last question of the day. Find the area of the shape below. Now, looking at this shape, it doesn't look like a shape that we've dealt with yet. So what I'm going to do is I'm going to cut this shape into pieces, into shapes that I do know how to deal with. So I'm just going to cut these into rectangles. So I draw an auxiliary line in, and that creates my first rectangle that is 6 by 2. If this whole length is 6 down here, and I've used up 2, that means that from here to this point is 4 in length. So I can draw another rectangle going straight up here, and that will give me a length of 4, 4, and 8, because 6 plus 2 gives me 8, and then from earlier the whole thing was 6. 6 minus 2 gives me 4. That also leaves me with 1 left over up here because the whole thing was 5. Next up, I'm going to draw another line segment in, giving me a 4 by 1 rectangle. So as we can see, we got a 4 by 1. And lastly, our last rectangle over here, we have a 6 by 8 rectangle. At this point, I can go ahead and use the area of each of these rectangles and then just add them together. So area is equal to 6 times 2 plus 4 times 8 plus 1 times 4 plus 6 times 8. So again, 6 times 2 plus 4 times 8 plus 1 times 4 plus 6 times 8. Multiplying these out, this will give me 12 plus 32 plus 4 plus 48. 32 plus 48 will leave me with 80. 80 plus 12 is 92. 92 plus 4 is 96 units squared. And that's our final answer. All right, guys, thank you so much for watching today. If you have any questions, please let me know. But I hope that you have a great rest of your day. Take care.